All right, 12.5 deals with probability of independent and dependent events. So an independent event is going to be where two events occur and they have absolutely no effect on each other. So pretty much the probability we've been doing so far has been that of independent events. They give you a formula right here. So the probability of both A and B happening is the probability of A times the probability of B. And like I said, these are pretty much the ones we've already been doing. So it's just an and problem. And you're going to be multiplying the two probabilities together. So for example, one talks about a game machine. It claims that 1 in 15 people win. What's the probability that you win twice in a row? Well, the probability you win the first time is 1 out of 15. Second time would be another 1 out of 15. So you win the first and the second. You go ahead and multiply that out to get 1 over 225. For number 2, you got a bag contains 3 red, 7 white, 5 blue. You draw 3 marbles. And the keyword here is you're replacing each one after drawing the next. So you pull the marble from the bag and then you're putting it back in. So they want to know what's the probability of drawing red, blue, white. So we need our total here. Total is going to be 15. And then from there, we have 3 events occurring, putting the marble back in each time, and then we need the probability. So you got, for the red, it would be 3 out of red. For the blue, it would be 5 out of 15, and then the white would be 7 out of 15. Go ahead and multiply it all out again, and you're going to get 105 over 3,375. You can simplify that down to be 7 out of 225. All right, number 3 would be the same deal. So you go ahead finding probabilities again. The key on this one is that your first 2 probabilities need to be women. So it says, what is the probability if the next 3 customers you have 2 women and a man? So first 2 would be women, third one would be a man. Again, you're going to multiply them all together. All right, moving on. Number 4 deals with two-way tables. So we've pretty much already talked about these earlier in the year. They ask you to find different probabilities. So the first one, they want you to find the probability that a listed student attended the camp. Again, the key is to figure out what were the total that attended. So you go ahead and add these all up. Add them all up is going to give me to 478. And then I want students that attended the camp. So attending would be this first column right here. We go ahead and add them. I'm going to have 220 out of 478. Again, you have to go ahead and simplify it. So we go down to 110 out of 239. Like I said, we've done the two-way tables before, so you should be able to do B3 on your own. The last type of problem we're going to talk about today is dependent events. This is the new one. It still shouldn't be that bad, though, if we think a little. So for a dependent event, it's 2 events where the outcome of the one has an effect on the other. And these would be ones where we don't replace. So we look at number 5. It says we randomly select 2 cards from a standard deck. Find the probability that the first card is a diamond and the second card is red if we replace. Okay, so that means we're putting the card back in the deck. So for A, probability we get a diamond. There's 13 diamonds in the deck out of 52. I now put the card back in, and then I draw again. So if I put the card back in, we're still out of 52. They now want a red card, so there's 26 reds in the deck. That would be how we do it. We're multiplying because we want a diamond and a red. When we go ahead and do that, it's going to end up with a probability of 1/8. For B, you do not replace, so I pull the diamond from the deck. So again, the probability of getting a diamond is 13 out of 52. The change is on the second one. So if I don't replace, I take the diamond, I throw it out. There's now 51 cards in the deck. And then the diamond was also a red, so we are down 1 red card. So instead of 26, we're now at 25. Multiplying it out and simplifying is going to give me a probability of 25 over 204. And that's it for section 12.5.